think about in the industrial segments, right now, we still are in the early stage of the curve of adopting technology. I do think there's huge gains to be had. I do think the human's going to play an important role. Of course, you can't have any conversation without what does it mean to adopt AI in manufacturing.
As 2026 approaches, a powerful transformation is taking shape across American industry and infrastructure. Artificial intelligence and advanced digital technologies are moving beyond the screen and into the systems that power everyday life, from factories and grids to data centers, rail systems, and buildings. For this special year-end episode of The Optimistic Outlook, Siemens USA Interim CEO Anne Fairchild sat down with Del Costy, President and Managing Director for Siemens Industries in the Americas, in Washington, D.C., to explore the industrial technology trends to look out for in 2026. Together, they unpack the challenges manufacturers face and the efforts underway to harness industrial AI and digital twins. Join us for a forward-looking conversation about the technologies, talent, and investments shaping a new industrial tech sector in 2026 and beyond. Let's listen in.
Del, welcome to Washington. We're so happy to have you.
Well, I appreciate it. I love being here.
I appreciate the opportunity of sitting down with you on the Optimistic Outlook. And let's dive right in. You've been on this podcast before to share what's happening in American manufacturing. From your conversations with customers across the country, what are you hearing? What are their top priorities for 2026?
Obviously, there's global competition. There's always been global competition, but things feel different now. I would say there's a pressure on manufacturing that's been increased over the last few years, and it's putting a re-emphasis on, I would call, advanced manufacturing, advanced production techniques, and what does it mean to drive advanced technologies on the shop floor? And so that's an element of it. How do we modernize our production capacity and capability to bring more flexibility to it? But there's also a change in the workforce that's happening, and how do we ready manufacturing for the workforce or production with the workforce? So those are the challenges we're dealing with. And of course, you can't have any conversation without what does it mean to adopt AI in manufacturing.
Yeah, absolutely. And you talk passionately about adopting technology at the speed of relevance. I love how you have used that language in the past. Help us understand the technologies that are most important to manufacturers right now and what to look out for in the year ahead.
I'm full disclosure, I shamelessly stole that from one of our aerospace and defense customers. They said it, and I thought this is the perfect way to represent what it is we do. I've been in software for over 25 years now, and I always think back to the way it was when I started versus the way it is today. And we used to work on these projects, and we would go through a whole phase of detailing out requirements. It could take 90 days plus, and then we would get everyone in the room. We'd figure out the architecture for the system, and we would build out the system over a series of 6-9 months, potentially even longer, depending on the complexity. And then we would bring users in, and we would kick the tires on what we built, and then we may have to go through a change cycle, and then we'd go through a whole test, and it could be 2 years plus before what we ideated of what we wanted to do with the customer got implemented. That's not speed of relevance, because with the rate of change of technology today, can you imagine what the different technologies we'll be dealing with in 24 months? We can't wait. We need much quicker turnaround time on sprints. And getting the technology. So what I love that we've done, and it's been one of my favorite things that I've gotten to watch over my career in technology, is when we went to digital thread mapping, I thought that was a huge, huge step in the right direction, because we mapped out, according to our customers' business process, the key processes that drive their organization, from the new product introduction cycles to production capability on the shop floor.
So Del, help me understand when we talk about the digital thread, what that really means. Let's break it down for our audience.
So you'll hear a lot of companies talk about digital twin. It's a virtual representation of what's happening in the real world. Why is that important? The more I can validate and verify my ideas through simulation, the more accuracy I'm going to have when I go from this virtual environment to the physical world. that allows me to take a lot of errors and delays out of the system because I've considered the one thing that's wonderful about simulation done right. I can go through tons of iterations and I'm doing it on a computer. And so I'm analyzing all the potential on the computer. That's what we talk about when we talk about comprehensive digital twin, because we're representing so many facets of the model, whether it's electronics, electrical, mechanical, software. We're looking at all that in a multi-physics way, product, process, production. So that validation is really important. The way I make sure I have high fidelity in that comprehensive digital twin is through the digital thread. What are all the functions that I need to connect from advanced engineering to engineering to simulation to manufacturing planning to production? How can I bring all of that data together in a cohesive way so as the product and process and production mature, I'm understanding that I'm adding fidelity to the digital twin.
Let's talk about data. A key tech theme emerging is the need to help manufacturers take advantage of their data, being able to leverage industrial AI in the operations. We know many companies are still struggling with their deployment. How does that start to change in the year ahead?
Any great sports team, it's not about just a collection of the best athletes. It's also, are you doing the basics? I don't think that's any different here with this wave of AI, especially when we talk about the industrial sector. And there's a lot of studies out there in terms of which companies are having success with AI, what percentage of projects are successful, and you can read all different types of studies. There are certain cases where success is happening, others not so much. The industrial sector has been a little bit more of a challenge. Now, I'm going to go back to what I just said. Companies really need to have the investment in the digital thread capability, the mapping of the data types. Are they connected properly? Do I have the ability to understand my data? And then the idea of digital twin. Do I have something referential that I can go and validate all this great insight AI is going to bring to me? Because I'm in the industrial sector. We don't have large language models. We can train models on voice and on data and on images, but that robust large language model for engineering and production data really isn't there yet. That needs to be built. And so having the digital thread capability, having digital twin capability is really important. And the other factor I'd bring, I do think the race for success in AI in the industrial sector, I do think there's an important component, and that is processing data on the edge. When I train these models and now I'm bringing in data on a real-time basis, am I collecting that data, going off to a data lake and doing analytics on it, getting some insights and bringing them back? That takes time. And if I want to make sure that inline quality is happening with AI-based vision systems, I need to recognize that activity at the spot. And so processing that information on the edge in a production environment to give me that millisecond response time is very important.
Absolutely.
So I think those are some key factors that industrial companies need to think about this differently than let's say if I'm in insurance or banking or some other institution where I don't have these heavy engineering challenges.
Let's take this a step further and really think about what's possible for manufacturers once their data starts to generate value and insights.
Yeah, there's a ton of opportunities for quick wins here. I've said this before in talking about this subject. Every manufacturing or production environment needs to take a step forward. One, in ensuring that you're actually collecting data. You don't know where data is going to bring you value, but I can tell you this, you're not going to get any value on data you're not collecting. And so one of the first things that we need to do, and we talk to a lot of companies of all different shapes and sizes, is let's make sure we are instrumenting things on the shop floor. We're actually in a position to collect data. And it's amazing. We've done some projects for companies when we were delving into sustainability. How do we save energy? And it's very expensive to run production facilities. And am I wasting energy running processes when they don't need to be run? I understand how I need to build product. And if I don't need to run a certain machine or process, then let's idle it. Let's conserve energy on that. There are applications that are very easy to install that we can get those benefits now. but it's a down payment on what we need to do to start getting an advantage of building a digital model or digital twin or framework, data fabric, as we like to say, of the facility. Now, once we have that in place, there's so much more we can do, but we have to start by getting that in place.
And none of this is possible without people. So what's the role of workers in driving this tech transformation forward, and what are the skills that are needed to be successful?
Yeah, there's a lot of headlines on AI replacing jobs. The future isn't about replacing the employees, but it's about changing the way the employees are going to work. And I think we've seen that throughout history. I mean, jobs, a large majority of the jobs that exist today didn't exist 50 years ago. Technology's changed what we do, and I think that's going to continue to happen. We talk about human-centered innovation, but how do we give the human in the loop the tools that they can process information more accurately and faster than ever before? And so we can bring that human intuition to it. To me, that's how we continue to push the envelope. When we think about in the industrial segment, right now, we still are in the early stage of the curve of adopting technology. I do think there's huge gains to be had. I do think the human's going to play an important role. And especially when we think about how do we need to adapt the shop floor, what information do we bring to the worker with operations? Right now, we see it. We spend a lot of time on the shop floor, and candidly, a lot of error codes hitting at a machine or line level or plant level that candidly we just work through, don't necessarily diagnose. By getting proper contextualized data now, we can understand what those error codes are quickly. We don't have to shut a line down. We don't have to go off and study a bunch of data. This is where AI is going to help us when we build that, again, data fabric correctly, and we've got proper ontology. We understand that the digital twin of the factory. Now we're going to be able to get those insights really quickly, and I think make the worker far more impactful on the shop floor.
It's not about workforce displacement, AI eliminating roles. It's really with the creation of new roles, and Siemens is committed to training workforce. I mean, we've just announced over 200,000 that we will train. That's not for Siemens. We will benefit from that as well, but it's for our customers. It's for America to help ensure that the workforce is properly trained and oriented towards AI skills going forward. I think these positive cases, examples, they need to be highlighted and communicated more broadly, I think, to ease sort of the societal acceptance of where we're headed. So what excites you about our future and the impact that we can make on American manufacturing?
Let's face it, our employees obviously have lives, and those lives aren't on a convenient schedule that happens to fit in 3 8-hour shifts. What if, because of data, what if because of line connectivity or cell-to-cell or work cell-to-work cell communication, what if we could introduce a whole level of flexibility in the way the worker participates in the job?
Amazing.
We could significantly reduce things like absenteeism because we've catered to the worker in a way that allows that flexibility. When you start thinking about getting this data right, the flexibility we can bring to the worker experience is outstanding, and it doesn't have to be a bad thing. We don't have to have production inefficiency. We can actually be flexible to the worker. Again, reduce absenteeism, because those things that happen in life don't mean they don't have to show up to work, but give that flexibility, and the system helps adapt accordingly. Yeah. And the communication of machine to machine can let work happen as necessary and really take advantage of the worker participation. I think there's a lot of flexibility coming with all these advanced technologies that I think are going to be game-changing.
Thank you for being with me today.
Appreciate it.
Thank you for joining us on this episode of The Optimistic Outlook. Be sure to tune in for more conversations with leaders shaping technology for a better tomorrow. Please subscribe to The Optimistic Outlook wherever you listen to your podcasts, and be sure to share the podcast with a friend or colleague.